Hello, my name's Thanom and I'm from UNSW. Today I'm going to solve some problems from Math 101 Calculus, section 1.2 on absolute values, some parts from question 5, part A, B and one of the other parts at the end. So part A is an absolute value inequality. We're solving the absolute value of 3x minus 2 is less than 5. There's lots of ways to solve it. We could graph it. We could consider the absolute value as a distance. I'm going to solve it this particular way, but there's lots of ways to do it. Now, when the absolute value of something is less than 5, what's happening is that something, which here is 3x minus 2, must be between minus 5 and 5. When you absolute value a number, if it's going to be less than 5 in magnitude, it has to be somewhere between minus 5 and 5. So we can get rid of the absolute values by considering it just as 3x minus 2 between minus 5 and 5. Now if I add 2 to both sides, to every side really, we get 3x is less than 7 and it's greater than minus 3. And then when I divide by 3, I have x is less than 7/3 and greater than minus 1. So this is the solution to our inequality, but we can write it with set notation. X is in this set from minus 1 to 7 on 3, not including the ends, which is why we have round brackets there. So that's just one way to solve that absolute value inequality. Part B is a similar question. It's an absolute value less than or equal to a half. It's slightly more complicated though because this is a quadratic inside here. So I want to solve this question a slightly different way. I want to graph it just so we can see what's going on. And also because I didn't graph any absolute values that looked like this earlier in the videos. So first of all, we're going to sketch y equals the absolute value of x squared minus 1. To do that, we sketch just x squared minus 1, which is a parabola that's been shifted down 1 unit. It's got x-intercepts of plus 1 and minus 1 here. Now, this is x squared minus 1. We want the absolute value of that. So anything that's positive is going to stay positive. So it's just got an equation x squared minus 1 still, because they're just staying positive. But this section that's negative, we're going to absolute value it. We're going to make it positive. We're going to reflect it. And so that reflects up to 1. And this has the equation minus outside of x squared minus 1. So it's got a different equation with an extra negative in front. So this is the graph of the absolute value of x squared minus 1. We're asking when is that y value less than or equal to a half? Well, here's a half. So we can see that the graph is less than a half in here and in here. So we really need what these points of intersection are to write down the answer to our equation there, our inequality. So let's find those points of intersection. These ones on the outside, let's call them 1 and 2. We're going to find those by solving x squared minus 1, because they've both got the equation x squared minus 1 equals to a half. Okay, so for 1 and 2, actually let's do it down here. So for points of intersection, now, if we're solving for these ones, we're solving x squared minus 1 is equal to a half. So x squared must equal to 1 and a half, or 3 on 2. So x must be the positive or negative square root of 3 on 2. So that's these x-intercepts here. Positive square root of 3 on 2 and the negative square root of 3 on 2. Now, the other points of intersection, maybe let's call them A and B. For these points of intersection, we're solving negative outside of x squared minus 1 is equal to a half, because that's the reflected section there. So for A and B here, we're going to solve negative outside of x squared minus 1 equals a half. So that means x squared minus 1 is negative a half. X squared must be a half. So x is the plus or the minus square root of a half. So there are our intersections here. So here's the positive square root of a half, and here's the negative square root. Oops. The negative square root of a half. So we can see the absolute value of x squared minus 1 looks like this, and its y value is less than a half in between minus root 3 on 2 and minus root 1 on 2, and between square root of a half and square root of 3 on 2. So we can write down our answer. So hence, the absolute value of x squared minus 1 is less than or equal to a half when x is in this set, or this interval, from minus square root of 3 on 2 to minus the square root of a half, including both of those, so that's why I've got square brackets, or in this interval here, from the square root of a half to the square root of 3 on 2. Square brackets again, because it's less than or equal to here, they can be equal to those values on the end. 5e is a more complicated looking absolute value inequality again. So again, we're going to draw a diagram so we can see exactly what's going on. But because we've got two absolute value functions added here, we've got to be really careful about the equations of the pieces of our absolute value graph. Because this equation changes at 2, this equation changes at minus 2, and so we're going to have 3 different equations for this piecewise graph. So let's just see what's going on before we sketch anything. Actually, we'll write down that we want to sketch. Why? Because the absolute value of x plus 2 plus the absolute value of x minus 2. To do that, I just want to sketch each of these separately and look at their equations and when they're changing. So just a little diagram here. Absolute value of x plus 2 is an absolute value graph shifted left 2. The equation on this side is x plus 2. The equation on this side is minus outside of x plus 2, so that's minus x minus 2. This section, x minus 2, is an absolute value graph shifted across right 2, so that's here. It's got an equation x minus 2 on this side, but this equation here is minus outside of x minus 2, so that's minus x plus a 2. So what's happening is we're adding these together, but on this side of 2, we're going to add these equations. In between minus 2 and 2, we're going to add this equation with this equation, and then left of minus 2, we've got 2 different equations to add there. So this graph here, so y, which is the absolute value of x plus 2 plus the absolute value of x minus 2, it really is x plus 2 plus x minus 2 for x larger than 2. And it's really x plus 2 plus minus x plus 2 for x between minus 2 and 2. So we're talking these equations, we're adding in between here. And it's really a minus x minus 2 plus a minus x plus 2 for x less than or equal to minus 2. So we're adding these 2 equations for this side of minus 2 there. So I'm just going to have to spill over here. So this is 2x when x is greater or equal to 2. This simplifies to 4 for x between minus 2 and 2. And this simplifies to minus 2x for x less than or equal to minus 2. So we've got to graph this piecewise function, but it's got 3 pieces here. Okay, so this is kind of our rough working just to work out how to sketch this graph. Okay, so let's sketch our main graph. So between -2 and 2, our graph is just 4. So that's easy enough. Our y = 4 is just a straight line, horizontal line 3, 4. So that's this section done. Y = 4 between -2 and 2. Y = 2x when x is greater or equal to 2. Now 2 times 2 is 4, so actually it does go through this point. Y = 2x is actually a straight line, gradient 2, like this, but we only want the section greater or equal to 2, so we only want this section up here. So this has the equation y = 2x, and that's for x greater or equal to 2. Similarly, -2x goes through the origin, has a gradient -2, which means it's passing through -2, 4 again. So in fact, that's coloured in. We only want the section less than -2, so we want this side here, and this has the equation y = -2x over there. This has the equation y = 4. Okay, so this is our sketch of y = the absolute value of x plus 2 plus the absolute value of x minus 2, which we worked out its piecewise equation to be 2x for x greater or equal to 2, 4 for this section, minus 2x for this section. Now, the question is asking, when is that graph less than 7? Where's my orange whiteboard marker? So this is less than 7. Well, 7 somewhere up here. So that graph is less than 7 here, here, and here in all these sections. So we need to find out these points of intersection. If I can find those points of intersection, I can answer the question. So I want to find these points of intersection A and B, then I can answer it. So for points of intersection, now for A, we're going to solve minus 2x is equal to 7. So the branch has the equation, that branch has the equation minus 2x. We want to know when that's 7. Well, that's when x is minus 7 on 2, or minus 3.5. For B, we want to solve 2x, because that's the equation of that branch, equals 7. That's when x is 7 on 2, or 3.5 if you like. So hence, we can see from our graph, the absolute value of x plus 2 plus the absolute value of x minus 2 is less than 7 when, well, this value is minus 3.5 or minus 7 on 2. This value is 7 on 2. So our graph is less than 7 for all the x values between minus 7 on 2 and 7 on 2. So that's when x is in this set from minus 7 on 2 to 7 on 2, not including the ends, which is why we have round brackets there. So this is our final solution to that question. To find it, we had to sketch this graph. To sketch that graph, we had to work out the equations for each piece and put them together. And then we had to work out when is that the y value of that graph less than 7, and that involved finding some points of intersection and reading the answer off the graph.